Hello, this is Simple Math for You. Today we are going to continue the revision for end of term 1 exam for the year 25-26, and this is part 2. Part 2 is discussing chapter 4 or module 4 that was already explained in many YouTubes or many videos in the channel in module 4. So this is a quick revision or a recap. Let's start by this question 39. Which relation is a function? So to know the function, what is the function? Function is a relation in which each element in the domain is paired with one and only one element in the range. Means if the domain contains values or includes values, you cannot have two images for a certain element or one element. Means you cannot be at the same time in class 1 and class 2. So this is not acceptable. However, we can share the output. For example, element 1 and 2 can share the same class. So this is generally the definition of the function. Now, for this one, I start by this one. Is this a function? It's very clear here that each element here is paired once. So there is nothing wrong with that. Yes, I know that -2 and 2 both share the output 3, but there is no issue about that. There is no problem. This is a function since each element in X is paired once. So yes, this is a function. Now let's move to graphs. For the graphs, the easiest way to check whether a relation is a function or not is by using vertical line test. Means I will pass a vertical line at any point of your choice, any point, any time, anywhere. It should only passes once. It should only pass once with one point of intersection. So if this is the case, then yes, it's a function. If not, like this one, for example, here at this point or at this line crosses the graph at two different points. That means this is not a function. So this is not a function. So in this case, we have 1 and 3 are functions, while others are not. Here he's asking which one is not a function. So let's check by one. Now, here is a table here. What do you notice? We notice that 5 is paired twice, once with -3, once with 2. It means like, for example, you are in 2 countries at the same time, or you are in 2 different classes at the same time, which is not practical. So this is not a function. Okay, let's see this. What do you notice? 4 is the problem. From 4 coming 2 arrows. It's paired twice, once with 2 and once with 5. So this is also not a function. While this one is a line, and all lines are functions except the vertical line. For example, the vertical line, it's not a function because if you pass a vertical line test, it will pass billions of times here. So all the lines are functions except the vertical line. So this is definitely a function because if you pass a vertical line, it will pass only once at any place you choose. So this is a function. He is asking about not a function. So 1 and 2 are not functions, and I will choose A. Okay, let's see here. Identify the domain and the range. What is the domain? Domain all values of X that are used. And in this case, all of this. So our domain is the list of numbers, -2. You should list them. Don't say X. 7, 8. So it's the input, actually. The input usually is the domain. The range is all values of Y that were used. Here, this is Y, which is the output. And in this case, what are the numbers that are used? We have only 3 5, and 6. As you see, 7 was not in the range. It was not used. Is this relation a function? Yes, it's a function because for each input or for each element in the domain, there is exactly one output. And we agreed on that. Now, let's go to something else, which is x-intercept, y-intercept. What is x-intercept? X-intercept is where the line crosses the x-axis. For example, if I draw any line like this, for example, this is called x-intercept. Yani, for example, let's say we have here line passes through these points. It's also for any other graph, but yani your lessons are only including lines now. So here, this is the point of intersection between the line and the x-axis. This is the x-axis. So this is called x-intercept. X-intercept here, in this case, is 3. And usually for x-intercept, y is 0. That's why this point is 3, 0. While y-intercept is where the line crosses the y-axis. And this this is 4, sorry. 1, 2, 3, 4. This is 4. 4 and 0. For y-intercept, let's erase it again. So x-intercept is 4. I counted wrong here. This x-intercept is 4, y0, because this is passing through 4. While y-intercept is 3 here, because here x is 0. And the line crosses the y-axis this. In this way, x equals to 0. For x-intercept y0, for y-intercept x is 0. So this is طبعا just for explanation or reminding you, but this is not the question. The question is asking you to find or to graph this function using x-intercept and y-intercept. So let's start finding them. This is the original function. So first, let's find x-intercept. We said to find x-intercept, you will assume y is 0. So what will happen? This will be 0. Done. So 4x is negative 16, and you will solve the equation. So x is negative 4. Okay. The same equation now. I want to find y-intercept. So you have to assume x is 0. For x is 0, that means this will be cancelled, and we have 8y is negative 16, and when you divide, y is negative 2. So this means the point here is negative 4 and 0, and here it is 0 minus 2. You go to the graph paper, and let's plot. Where is minus 4 and 0? This is minus 4 and 0. At minus 4, this is x-intercept. Y-intercept at 0 minus 2, which is here. And you will match the line over there. This is your line. And this is a very good and a nice way to graph any line. Let's practice again, x-intercept, y-intercept. So to find x-intercept, assuming y is 0. So what will happen? This will be cancelled. Y is 0. So it will be 3x equals 24. Divide by 3, x is 8. So this is x-intercept. For y-intercept, x is 0. So this will be cancelled. So 2y is 24. Y is 12. When you divide by 2, it's 12. This is y-intercept. It's not asked here to graph, so we will leave it. Okay, let's move to the next question. Next question is talking about the slope and the slope-intercept form and whatever. So let's see this question 44. What is the slope of the line that passes through these points? If you are asked about the slope, directly you can use the slope formula, which is y2 minus y1 over x2 minus x1. Remember, difference of y up, difference of x down. And we can label them x1, y1, and this is x2, y2. And replacing -3 minus the -3. So this is 2 over 0, which is undefined. 2 over 0 is undefined. You cannot divide by 0 in the calculator, even it will give you error. And as you notice here, without calculating, you find that x is the same. X is the same means the line will be standing at -3 from the x-axis. It will be vertical line. And all vertical lines have undefined slope. Which points or point form a line with a negative slope? Just remember, positive slope will increase from left to right. This has positive slope. This has negative slope. It's decreasing from left to right. This has zero slope, horizontal line. Slope is 0. And for the vertical line that we just mentioned here, this is undefined slope. It's vertical line. This is the revision for all the lines. Now, what is the line that have which one is with negative slope? We will find the slope for each one of them. يعني y2 minus y1, x2 minus x1. Let's check B. This one will have positive slope. Let's check this one. This will be correct. Because if you find x1, y1, x2, y2 to be 1 minus -5, it will be 6 over -4. So it is negative slope, irrespective يعني of actually simplifying. And this will be also with negative slope, and this will be with negative slope as well. Check alone, and you will find that this is correct. The slope of a horizontal line is 0. Yes, we have completed that. It's 0. While the slope of the vertical line is undefined. You should know that. Which best describe the slope of horizontal line? We just mentioned it's 0. Given line passes through 2 points, find the slope of a line. Easy. Same. Simplify. 4 over 8 is half, not 2. Remember that. Now, this is a good question because it compiles the idea of the slope with the proportions as well. Find the value of x so that the line passing through these points has the given slope of 3. So we have 2 points. One of the coordinates is unknown, and we have the slope. So this is the slope formula that we know. Let's replace with what we know. Slope is 3, so 3 equals y2 minus y1. This is x1, y1, x2, y2. y2 minus y1 means 2 minus -7. x2 minus x1 يعني 1 minus x. And let's simplify. 3 equals 9 over 1 minus x. So let's put this over 1 because it will not make any difference, and cross multiply. So we will say 3 times the whole expression 1 minus x equals 9 times 1. Distribute. Solve the equation. Divide. And x will be -2. This is similar, but now with a missing y coordinate. So we will do the same exactly. The slope is y2 minus y1. You can do it and check with me. And here we have 2 over 3 equals. Simplify, please. Better. Simplify before you continue as much as you can. Now cross multiply. So this will lead to 3 times 2 minus y equals 2 times minus 6. 6 minus 3y equals negative 12. Negative 3y equals negative 12 minus 6, which is negative 18. Divide by negative 3, so y is 6. This is y. Write the equation, or what is the equation in slope-intercept form? What is slope-intercept form? It is y equals mx plus b. M is the slope, b is the y-intercept. So he wants which one? Function A. Function A means this line. So we need to find the slope. To find the slope, choose 2 good points. I mean good points that have exact numbers, integers. Don't choose, for example, a point here or a point there. A point on the corner of the box. For example, this is a good point. This is a good point. This is a good point. 2 points are enough. So let's say we choose only this and that. You have 2 choices. Either choose coordinates of the point and apply slope formula. For example, you know that this is 0, 1, and you know that this is minus 3 and 3, and apply slope formula, or use rise over run. Rise over run. So you are going from this point to this point, rising down 2, so this is negative 2, the rising. You are running here 3. So the slope is rise over run, which is negative 2 over 3. You can even count and then decide that the slope is negative because it's decreasing from left to right, as we know. Okay, so which one of them has a slope negative 2 over 3? This is the only one with the slope negative 2 over 3. So I will choose C without even completing the B. Even if there is another choice with the same slope, what is B here? B is the y-intercept, which is 1. And it is very clear here that it is y equals negative 2 over 3x plus 1. Refer to the line graph below. For example, if you want B, by the way, you do the same thing. Choose 2 points to find the slope, and B here is this point, which is minus 3. Yani this will be something with y-intercept minus 3. You choose 2 points to find the slope. Any good points. This is one of the points. This is a good one I can see. And this is another good one. So you can find this is the rise, this is the run. The run is this positive slope. The run is 4. The rise is 1, 2, 3, 4, 6, 7, 8, 9, 10. So the slope here is 10 over 4 or 5 over 2, and it's positive. So this will be y equals 5 over 2x plus minus 3, and minus 3, the y-intercept. This is for graph B. It's not required, but it's for your information. Refer to the line graph below and find the following. Slope, he already has chosen for us 2 points. So you can choose slope formula, or you can use rise over run. 2 over 1, and it's negative. You can say it's negative 2 over 1, which is negative 2, rise over run. Or you can apply the slope formula. You can say it's 2 minus 4 over minus 3 minus minus 4, which is negative 2 over 1, which is negative 2. Same result. You should have the same result. What is y-intercept? Y-intercept is here. This is y-intercept, where the line crosses the y-axis, and it is located at minus 4, as you can see. Equation of a line, so y equals negative 2x plus negative 4, yani minus 4. Don't put plus minus. Moving now to transformation, describing the transformed function in terms of reflection, stretching, and dilation, translation, whatever. So let's start by the first one. Match the linear function with the correct description of how its class differs from parent function. Parent function of linear function is y equals x, or you can say f of x equals to x. Any additional part considered to do some transformation. For example, here there is a minus and there is a 3. The minus before the x, either it's out or in the group, it causes reflection. If it is outside, not grouped, يعني, it will be reflection across x-axis. And this number is multiply. Multiplication means dilation. Dilations mean compression or stretching, either compressed or stretched. And since it is not grouped, so it will affect vertical. So here we have vertical stretch. Why stretch? Because it's 3 and 3 more than 1. And this is vertical because it's non-grouped, outside the grouped. So this is vertically stretched and reflection across x-axis. So that means this will go to B. The other one is exactly the same, but as you see, all are inside the bracket. Inside the bracket, it's affecting horizontally, and everything will be reversed. We were saying that the 3 has done vertical stretch if it is outside the group. So if it's inside the group, reverse everything. It will be compressed horizontally or horizontal compressed, as he mentioned here. And the reflection, instead of being across x-axis, it will be across y-axis. So this will go to A. Let's solve more exercises. Here, minus is outside. We have two effects. Minus is outside, so reflection across x-axis. 5 is multiplied by the number outside the group, so it is vertically stretched. Why stretched, not compressed? Because 5 is more than 1. So we have reflection across x-axis here and stretch vertically. So stretch vertically, reflection across x-axis. So this will go to D. Now this minus is inside, so reflection across y-axis. 5 is inside, so horizontally compressed. عكس اللي قلناه قبل شوي. Opposite to what we have said. Here we have vertical stretch, so it will be horizontal compress since it is in group. So we will choose here C. Compressed horizontally and reflected across x-axis. Okay, let's see this one. Now this is adding. Adding in or out means translation. If it is inside the group, it will affect only left or right. If it is outside, up or down. So let's check now the results. Now, since this is added to 5 inside the group, it means moving to the left. So 5 units left. And this plus means going up. So 5 units up. 5 left and 5 up, which means B. Last one, K of X equals X minus 5 is just 5 units to the right, which is A. Graph translated 5 units right, so it's A. Determine the type of transformation of each function. We have 3 types of transformation. We have dilation, and dilation comes from multiplication. We have translation. It comes from addition. And we have reflection, and reflection comes by multiplying by minus, negative outside. Okay, so let's check one by one. First one, multiplication. So this is dilation. Dilation includes, by the way, stretching or compressing. So this one is vertical stretch. This one, there is a minus, so it's reflection, and this reflection will be across x-axis because the minus is outside. This is translation. Translation يعني sliding. يعني بحرك يمين شمال فوق تحت. And this will be outside, no group, so it will be up, vertical يعني translation, up 3 units up. This will be multiplication, yani dilation. And this dilation includes vertical stretch. This one, translation, yani sliding. And this will be 2 units down. Okay, here let's relate the parent function. Here we have here reflection across x-axis. And for the 4, we have vertical stretch. Here it's better to distribute the minus sign and combine like terms. So we will have here, 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 all the changes. 1, reflection across x-axis because it's not grouped. Number 2, we have vertical stretch. And number 3, we have 7 units up because it's not grouped with that one. Let's check this one. The minus sign is reflection across x-axis. The 3 inside the bracket added, so 3 units left. And for the minus 1, 1 unit down. Question 61. Determine whether or not each sequence is an arithmetic sequence. If it is, give the common difference D. When can we say that a sequence is arithmetic? If the difference between 2 consecutive terms is constant. For example, we are going to check the first one. What is the difference between the first term and the second term? It's 14. You can do it mentally, or simply you can subtract the new minus the old. 15 minus 1, 14. 29 minus 15, 14. 43 minus 29, 14. So all the terms are increasing by the same number, which is 14. So we will say yes. And he said if it's yes, find the common difference. So the D is 14. Let's check this one. Check it. You can check minus 2 minus 1 is minus 3. So this is decreasing by 3. 3 minus minus 2 is 5. So this was increasing by 5. Then is it arithmetic sequence? No, it's not. Next one, it's increasing by 4. You should check by 5, sorry. It's increasing by 5 and you should check until the end. So yes, D is 5. This one increased by 2, then increased by 2, then increased by 4. You can check. 10 minus 6 is 4. So no, it's not an arithmetic sequence. For this one, if you subtract 64 minus 72, it is negative 8. 56 minus 64 is negative 8. 48 minus 56 is negative 8. 40 minus 48 is negative 8. So all over the sequence, we have the constant difference, negative 8. So you will say yes, and the difference is negative 8. Now, fill in the values to make an arithmetic sequence. To be able to fill, we need to find out the difference. How much this term is increased. If you cannot do it mentally, we can find the new minus the old term. So it's minus 1 plus 4, which is 3. So this is added by 3. So what are we going to do? We are going to add 3 here. So minus 1 plus 3 is 2. Then as you see, 2 plus 3 is 5. So this was correct. And we are going to add again 3. It will be 8 if you can. If you want, again, it will be 11. Add 3 every time. Okay. Let's continue. Identify piecewise linear function. Now we are going to discuss the piecewise linear function. We call it piecewise linear function because it includes pieces, actually. Pieces. So each piece will have its own definition. Let's see. We have here piece number 1, f of x is equal to minus 2. So we can say y equals minus 2 when x is less than or equal to 0. So that means if you start assuming numbers, we will assume numbers starting from this critical point, which is 0. And then the second point will be less than or equal to 0. Choose any point, so we will choose -1. Now, why does it depend on x here? No, it's always equal to -2, irrespective of the value of x. So y is -2 here and -2 there. That means for x less than or equal to 0, when you plot, you will have something like this. 0, -2, which is this one, and we will close the circle to indicate that the first point is included because there is an equal sign under the less than or equal. So this is the first point. The second point was what? -1 and -2, so it's here. And this is the starting point, and this is on its way, so it's a constant going to this direction. As you see, this is the only option with this graph. If this piece was repeated here or here, you need to check the other piece. If, let's say, we want to check the other piece, which is piece number 2, which is x plus 1, when x is more than 1. When x is more than 1, you will also assume 1, but you will know that this is an open circle. You will take the first point and then choose another point which is more than 1. It's 2 or 3 or 4. Choose small numbers. Then replace the numbers that you are choosing instead of the x. So 1 plus 1, 2, and 2 plus 1, 3. If you plot the points 1 and 2, this is 1 and 2 as you see, and it shows that it's an open circle, so this was correct. 2, 3 is here, so this was the correct graph, definitely. Okay, let's see this one. Question 64. Given the function f of x is 2x minus 5, if x is more than 1, and 4x minus 3 if x less than or equal to 1. Now we are going to graph the function and then find the domain and the range. Starting, let's organize our work. Starting piece by piece. Piece number 1, y equals 2x minus 5 when x is more than 1. So we will generate our table starting with what? As we said, we should start by the 1. So when you start by 1 and you replace it here, 2 times 1 is 2. 2 minus 5 is -3. Another point, we can start 2. Why 2, not 0? Because we need more than 1. So 2, you replace it here. 2 times 2, 4. 4 minus 5 is -1. It's enough. 2 points are enough because it's a linear function. And then we will plot the points. 1 and -3 is here. And before you leave, you check. Is it equal? Is it equal to? Or only greater? It's only greater than 1. So you will put an open circle here at the beginning, at the starting point. Then 2 minus 1 will be here. So this will be your first piece. Okay, moving to the second piece. Y equals 4x minus 3 when x is less than or equal to 1. So this is the table that I am generating. We will start also by 1, and then we will replacing x by 1, so it will be 4 times 1, 4. 4 minus 3 is 1. Replacing x by something less than 1, so you choose 0. 4 times 0, 0. 0 minus 3 is -3. And let's start plotting. 1 and 1 is here, and now it's closed circle because there is an equal sign here. 0 and -3, it is here, the y-intercept, and it shouldn't be that thick. And then this is the starting point, and you will match, and this is the arrow. Now, what will be the domain? Okay, let's check the x values that we can choose from. We will use a number line like this. And the point that he is talking about only is 1. So we will put 1. He can use, or we can use values that are more than 1. So it's in this direction. And we can use also points that are less than or equal to 1. It's very clear here. If you look at the shaded region, we can use any number on the number line. We can use all real numbers. So in this case, it includes all the number line. So that means your domain here is all real numbers. Now let's check the range. Now I have two ways to find the range, either from the graph that I have done before or from the table. If you use the graph, let's check the y values. The range is the y values that have been used. Now, this was the minimum. Let's check here. This was the minimum for the brown, and it's going up, right? And for the blue, it was starting from here and used everything down. If you have a quick look here, the y values used are the brown or the blue one, includes all the y values, all the real numbers as well. So in this case, you can say all real numbers. This is one of the ways to check. Other way is to check using a number line as well. So I will use the number line and check the y values. The first y value here was -3 or -3. So I will put -3. And we know that it was open circle here. Okay. Now, after that, it becomes -1. That means it goes to the right. So we have used this part. Okay. The second table, which is this one, it starts from 1, and it was closed circle. And after that, it becomes -3. That means it went to this direction. And as you see, the shaded region covers all the number line, and that proves what we said previously, that the range is all real numbers. It's not always the case, but in our graph, it includes all real numbers. Okay. Now we will move to something called step function. And as you see, it is showing that it's a step function. It's like steps. Let's read the real life application. Joy wants to rent a surfboard. The cost is $13 for every hour rented, and any fraction of an hour is rounded up to the next hour. So it means that if you know that this is the hour, the first hour will be 13. The second hour will be 26. The third hour is 39. This is clear. But there is an additional part here saying any fraction of an hour is rounded up to the next hour. Means any fraction of an hour means half an hour, 15 minutes, 20 minutes, 30, 45 minutes will be all rounded to 1 hour. So that means if x is more than or 0 and less than or equal 1 hour, we will pay 13. And if x is more than 1 and less than or equal to 2, we will pay 26, because 1 hour and a half you will pay for 2 hours. That means also this one. That means this is the y value. And that means we are going to have interval of numbers all with one same value of y. Yeah. So let's see which one will be acceptable. This one will not be acceptable because both ends are open circles, that it's not defining even here for 1 hour, it's open. So we cannot say that it's 13 hours. So this one definitely is wrong. This one is wrong because it only defines the integers. It cannot have a value between 0 and 1 or 1 and 2. There is no value here defined in between. So this is definitely wrong. We have only now A and B to choose from. Which one makes sense? If you choose, let's say B or A, let's say start by A. A says what? 0 is paired with 13. Means if there is 0 hours, That means no hours were used, no time. You will pay $13. And if you have 1 hour, you will not pay this, you will pay 26. This is the closed circle, but the open circle, it doesn't define the value. So that means this is definitely wrong, and we will go for B, because B is a good choice. For example, for half an hour, he will pay 13. For 40 minutes, he will pay 13. For 1 hour, 13. For 1 hour and 10 minutes, he will go here and he will pay 26. So this is making sense, and we will choose B. Now moving to absolute value function. Remember that absolute value function, parent function, is absolute value of x. And it's always looking like this. It's the parent function looks like that. But if there is a transformation applied, then it can be reflected, stretched vertically, going up, going down, whatever. So let's see what happened here. In this parent function, there is a negative sign before. There is a 3 multiplied by the number inside the group of absolute value, and we have plus 6 outside the absolute value. Each part of those, the blue ones, will affect our function. Let's see our effect. The first one, the minus sign before, means it's reflection, and since it's outside the group, it will be reflection across x-axis. What does that mean? If you have the parent function originally here with the slope 1, 1, and both sides, reflection across x-axis will be somewhere here, keeping the same slope. So this is the first part. Number 2, what will the 3 do? The 3 here is multiplied by the x inside the group. Any multiplication means dilation. And since it's grouped, so it will be horizontal, either stretch or compress. Since 3 is more than 1 inside the group, so it will be horizontal, compress. And that means the slope will be more. It will be steeper or narrower. يعني the slope here, instead of being 1, it will be 3. So this will be like something like this. It will be 3. Okay, so reflection, then multiplication. Now, number 3, last transformation, is adding 6. Adding 6 outside means vertical translation, 6 units up. That means this red one will move. This is the last transformation. 1, 2, 3, 4, 5, 6 up, and it will be somewhere here. Which one you think is the best choice? Definitely it's C. Because if you check here, this is the reflection, the original reflection was with 1. Then here it becomes, look, the slope. The slope here is 3, as you see, 3 over 1, 3. Rise over 1 is 3. And then it moves 1, 2, 3, 4, 5, 6, as you see, up. So this is the best choice. Okay. Let's move to the graphing. Given the function, absolute value function, fill in the table, then graph the function. How can we fill this table? If the table was not there, this is a helpful hint that they're giving you the table. You should know that to graph any absolute value function, you need 3 important points. This point, which is called the vertex, a point to the right of the vertex, and a point to the left of the vertex. And that's why first we are emphasizing or focusing on finding the vertex. How can we find the vertex? The vertex is the point that makes what is inside the group equals to 0. So we will write x minus 8 is 0, and this leads to x equals to 8. This x equals to 8 will be at the middle, and that's why this is the coordinate, the x coordinate of the vertex. Now what to do? Choose one point below, one point above, one less, one more. But for more accurate results, we are choosing 2 points below. Oh, he has chosen 2 points below, 2 points above. Now, can we choose 7? Yes, we can choose 7, 6, 4. But why we are choosing 4 and 0? Because here there is a denominator 4. And if you choose numbers that are not multiples of 4, you will end up with fractions. And as you know, it's difficult to graph points with fractions on the coordinate plane. So that's why we will choose multiples of 4. And 2 points before, 4, 0, 2 points above, 12 and 16 are good. What are we going to do with these points? Every x chosen will be replaced instead of the x in the original function. So, for example, if x is 0, h of 0, yani x0 is negative 3 over 4, and you replace the x by 0 plus 1, which will be minus 3 over 4, absolute value of minus 8 plus 1. What is the absolute value of negative 8? It's just 8. 3 over 4 times 8 plus 1, it will be how much? There is negative 3, negative. So this will be negative 5. Negative 6 plus 1, it will be negative 5. And that will be, y is negative 5. That means the point will be input 0, output negative 5. So this is y. And then replace by 4, replace by 8, replace by 12. Every point will be replaced. Calculator can help a lot in this, but don't forget that you have to take the absolute value. Don't replace and then forget to take the absolute value. So if you replace, you will find that y here is negative 2, here is 1, here is negative 2, here is negative 5, and those will be our points. Then we will plot the points. 0 and negative 5 will be here. 4 and negative 2. 8 and 1. Then we have 12 and negative 2. This is somewhere here, yani, negative 2 here. The graph should be looking symmetric, of course. So if you continue graphing, it will look like something like this. Okay, trying to be accurate as much as we can. After plotting the point, of course, you are expecting that it's looking down or opening down because of the minus of the negative sign here. It will be reflected and shifted up 1 unit, as you see here. Now, what is the domain? For all absolute value functions without thinking, the domain is all real numbers. Why? Because we can replace any value of x inside the absolute value. What is the range? Range includes all the values of y that have been used. So as you see here, what is the value of y that have been used at the beginning, even the maximum value? This one. This is the maximum y that I can see here. And everything is below this point. Everything is below the 1. So that means y less than or equal to 1, or all numbers that are less than or equal to 1 is the best description. If it opens up, for example, if it opens up like this, it will be y more than or equal to 1. So you have to be careful about the minimum and the maximum. Now, can I do it mentally? Yes, I can. Here, there is a minus. So I expect that it's looking down. And it will be maximum, not a minimum. And this is our maximum. So directly, without even graphing, you can say y less than or equal to 1. Okay? That's all for chapter 4. And see you in the next chapter, which is chapter 5, part 3. Thank you so much.